Okay, this is the second podcast for Unit 2. It covers transition metals. We are still doing binary ionic compounds, but now I'm going to address some of those special cases. So, before I mentioned the group B elements, they have more than one possible oxidation state. Remember, oxidation state is essentially the same as saying charge. They can have more than one charge to their ions. So we use Roman numerals in order to show the charges. We also do this for group 4A. Okay, some of them do form ions, mainly tin and lead down here at the bottom, Sn and Pb. And they do have more than one oxidation state. Okay, so tin 2 and tin 4. And I'm going to show you how to get those oxidation states here in just a moment. So, when we go to name the cations, the transition metals, they can have more than one type of charge. And so we indicate their charge with the Roman numerals in parentheses after the name of the metal. Okay, so you need to know your Roman numerals. 1, 2, 3, 4 is IV, 5 is V, 6, and 7. That's as high as we count to for our Roman numerals. So if you're not familiar with those, okay, those are something you need to memorize and know. Commonly, you mostly just see 1 through 6, or really 1 through 4. So those are the ones that you will use the most often. So let's go ahead and try and name these here. We've got Fe3+. Well, Fe is the symbol for iron. 3+ tells you its charge. So since the charge is the 3+, you will use a Roman numeral 3. So iron, parentheses, Roman numeral 3, ion, like that. Is it wrong if you skip the parentheses? Yes, it is. Okay, if we look at the next one, Zr2+. You got to find Zr there in the transition metals. We got zirconium. Okay, and then this charge right here tells us our Roman numeral 2, ion. Got to include the word ion for these. Okay, you do the next one. Au is the symbol for gold. It has a 3+ right there, so Roman numeral 3, ion. Okay, try the next one. Fe2+, iron 2, ion. And then we've got copper 2, ion, and copper 1, ion. Okay, so these transition metals, they always need a Roman numeral with just a couple of exceptions, which I'll show you in just a bit. Okay, so if you want to go the other direction, copper 2 ion. Well, Cu is the symbol for copper, and then this right here tells us our charge, 2, and then plus. I always know it's positive. Okay, we only do this for transition metals. Metals are positively charged. They always form cations. Chromium 6 ion. So chromium, the symbol is Cr, and then the 6, you can write +6 like that, or you can write 6+. It does not matter, just as long as you have both the 6 and the plus. Okay, manganese 4 ion. Okay, manganese. Don't confuse manganese and magnesium. Manganese is Mn, and then that Roman numeral 4, we change that there to a +4. Cobalt 2 ion. big C, little o, and a +2. Remember, you cannot have a big C and a big O. Okay, I'll be watching your letter size, making sure you're writing your symbols properly. Okay, so transition metals need Roman numerals except for these three elements. Silver is always a +1, zinc is always a +2, and cadmium's also always a +2. So if you notice on the periodic table, they form this little L shape, little backwards L. Silver, cadmium, and zinc. You might want to mark those on your periodic table so you know that. So this is the same thing again. Some of the transition metals only have one ionic charge. Silver is always a +1. Cadmium and zinc are always a +2. You would not use a Roman numeral. Is it wrong to use a Roman numeral on those? Yes, it is. Okay, so this is probably going to be what is the most challenging for some of you here, is naming these formula units, because we don't know what the charge is. So if we take a look here, we've got manganese and then O2. So you always name the metal first. Manganese. And since manganese is a transition metal, I know I'm going to need parentheses for my Roman numeral. And the O2 is called oxide. Okay, so now I have to figure out what my Roman numeral is. Okay, since I have two oxygens, I have to look up the charge on oxygen. If I look on my periodic table, the charge of oxygen is -2. Well, I've got two of those, so that's the same as a -4. I know these need to cancel out to 0. Okay, so the -4 has to be counterbalanced by a +4. So the manganese has to be a +4, which would give us a Roman numeral 4. So manganese 4 oxide. Let's look at the next one here. AuCl3. Okay, Au is gold. I'm going to need Roman numerals, so I just put in kind of placeholder parentheses to remind myself, and then I name the last word. Cl3- is chloride. Okay. And then I need to figure out the charge. Let me show you another way to figure out the charge. Make a little algebra problem. I've got Au plus, and I've got 3 chlorines, 3 Cl's, and I know all the charges have to total out to 0. Okay? So if I've got Au and my 3 chlorines, look up chlorine on your periodic table. All chlorines have a -1 charge. So Au plus a -3 equals 0. Au minus 3 equals 0. So Au has to equal a +3. So now I know that is my Roman numeral. Okay, Roman numeral 3 there. So this is called gold 3 chloride. Yes, this method does take a little bit more work. Okay, but the good thing is you're always right. Okay, sometimes when students do it like this, chlorine's a -1. I've got 3 chlorines, so that's a -3, so that has to be a +3. They don't always do this properly, or they'll make mistakes. Okay, so let's try the next one. Cu3P. Okay, so Cu3P. I know this is copper. It's a transition metal, so I'm going to need some Roman numeral. And then phosphide is the name of the second word. Okay, so let's do the mathematical way. How many coppers do I have? I have 3 coppers and 1 phosphorus, and their total charge has to equal 0. Okay, we don't know what copper is, so we just leave it as 3 Cu. But we do know that phosphorus has a -3 charge. So 3 Cu minus 3 equals 0. 3 Cu equals plus 3. So Cu has to equal a plus 1. So we can divide each side by 3. So now I know my charge up there, plus 1. Okay, this takes a lot of practice. Okay, it's not the easiest thing to get the hang of. So this is called copper 1 phosphide. Okay, if we look at the next one, AgCl. Okay, name it, silver. Is silver a transition metal? Yes, it is. But silver is one of those exceptions that does not need a Roman numeral. So I just call it silver chloride. Okay, take a look at the next example, SnF2. Okay, tin is in the group 4. Okay, for group 4, for the lead and the tin, you also need a Roman numeral because those charges varies. So I've got tin, some Roman numeral, and then fluoride. Okay, if you look up fluorine, fluorine has a -1 charge. I have 2 of those, and that's a -2. So this Sn has to be a +2. So my Roman numeral is 2. Tin 2 fluoride. Okay. And then the last one, try the next one out. I'm going to show this one mathematically. You've got chromium, some Roman numeral because chromium's the transition metal, oxide. Okay. If we do it the mathematical way, I've got 2 Crs and 3 oxygens, and they all have to total 0 by the time I'm done with them. I don't know what chromium is, so I just carry that charge down. But I do know that oxygen's a -2. So all I do then is solve my math problem. So 2 chromiums has to be a +6. We want to find out what 1 chromium's equal to. So 1 chromium's equal to a +3. That's what I bring up here. And this becomes chromium 3 oxide. Okay, honestly, like I said, this is going to be some of the hardest things for some of you in this chapter, is just getting the hang of those there. Okay, writing formula units from names. Going the other direction's a lot easier. Okay, I've got Fe2 oxide, or iron 2 oxide. So iron is Fe2. I know my charge is 2+ from that Roman numeral. Okay, oxide is oxygen. It's a -2. If I try and put these together, do they cancel out perfectly? Yep. So I just write FeO. Okay, iron 3 oxide. Well, now that Roman numeral is changed, so my charge is changed. But oxygen's still a -2. And that'll affect my formula, Fe2O3. We still just cancel them out like we did before. Okay, lead 2 sulfide, Pb. Because of the Roman numeral 2, it has a +2. Sulfide is sulfur. These cancel out perfectly, PbS. Lead 4 sulfide, Pb +4. And then sulfide's still a -2. But this time it's going to take 2 of those sulfides, and I get PbS2. And then for our last example, uranium 6 fluoride. You'll notice uranium is in the inner transition metals. Okay, down at the very bottom of the periodic table. They still need Roman numerals also. So uranium there is a +6. The fluorine is a -1. So see, the uranium's a +6 from the Roman numeral 6. So that means I need 6 of these fluorines to cancel out. And my formula is UF6. So those are my final answers. So going in the other direction, it's not so bad. But sometimes trying to figure out that Roman numeral, that's going to be what's a challenge for some of you.